All right, welcome to warm-up number 14. We've got this quadratic equation. This is going to be a parabola. We're going to be graphing this. And we'll figure out this information to help us graph it as we go. So let's start with the y-intercept. To find the y-intercept, you just have to plug in the you have to plug in 0 for the x's. So both of the terms where I'm plugging in the 0 are just going to disappear, right? Because this is 0 times 2, which is 0. This is negative 7 times 0, which is 0. So all that's left is y equals 3. So in standard form, the y-intercept is just going to be the constant, the c value. Okay, so there's my y-intercept. I'll put that into the graph. So there's where my parabola is going to cross the y-axis. Okay, to find the x-intercept, I'm going to plug in 0 for y, and then solve for x. Okay, and so my best option here is to try to factor this if this is factorable. So I'm going to attempt to factor this using a modified diamond problem since I've got that 2 in front of the x squared. Alright, so I'm going to take the 2 and multiply it by that end number, changing the problem here. So that's going to give me x squared minus 7x plus 6. So the 2 disappeared from the front. I multiplied it by the 3. Now I've got a trinomial that I can factor with a diamond problem. So I'll put the negative 7 on top and the 6 on bottom. And then I'm looking for two numbers that multiply to 6. The same two numbers add to negative 7. So let's think about how to multiply to get 6 using integers. Not that many options. There's 4 options that I can think of. And only one of those is going to add up to negative 7. That's this one. Okay, so that's going to help me to factor this trinomial. Okay, but I still have to, I changed the trinomial at the beginning, so now I've got to change my factored version. So in the beginning I multiplied by 2. Now I'm going to do the reverse. I'm going to divide the number parts by 2. So I'll just write that as a fraction. Okay, and then I want to simplify this as much as I can. See if I can squeeze this in there. As usual, I didn't leave myself enough space. So 6 divided by 2 is 3, right? 1/2 I can't reduce, so I'll pull the 2 out in front of the x. The 1 falls to the ground, and then hopefully you can see that this says 2x minus 1 times x minus 3. Remember, this is all what 0 equals. Okay, so I've still got to use the 0 product property here to find the x values. So one of these two products has to equal, one of these two factors has to equal 0. So either 2x minus 1 equals 0, or x minus 3 equals 0. And let's solve both of those. Here I'll add 1 to both sides, and then divide by 2. And then here I just add 3. Okay, so that was kind of my second phase over there. All right, so here's my x-intercepts, 1/2 and 3. Okay, let's put those into the graph as well. 1/2 is about here. 3 is about here. Okay, I know this parabola is going to open upwards. So it's looking like it'll work with that. So the vertex should be somewhere down here. I'm not sure exactly where, but somewhere in there. So let's figure out where that vertex is. The way I'm going to do that, first off, I'm going to find the axis of symmetry. That's going to be the line that that's right in the middle of the vertical line. That's going to divide my parabola in half. So the formula for that is x equals negative b over 2a. Here the b is negative 7, so I've got negative 7 in the numerator, and then the a is 2, so 2 times 2. All right, let's simplify this a little bit. I've got 7 over 4 then. Okay, so the axis of symmetry is not just 7/4, it's the line x equals 7/4. So the x equals makes it a vertical line. Okay, or you could say that would be 1 3/4 or 1.75. So maybe I'll write it like that just to make it easier to visualize where it goes on the graph. Okay, so 1.75, that's 1.75 on the x-axis is somewhere right about there. I'm just eyeballing it. Okay, and then I'm going to draw a vertical line 1.75 units to the right of the y-axis. Okay, So there's my axis of symmetry. Now, if that's the middle of my parabola, I know my vertex is going to go somewhere on this line, okay? So my vertex is going to be the point 1.75 something. I just need to figure out what that something is, okay? So this is going to be my answer for number 4. Now to figure out what that something is, I'm going to plug this x value, 1.75, into the original equation. So really I'm finding f of 1.75. Finding what the y value will be when I have an input of 1.75. Okay, so I'm plugging 1.75 in here and also here. Okay, and then I'll start sorting this out using PEMDAS. So I'm going to do the exponent first. So let's see. Here, I'll use my calculator here. 1.75 squared is this number. And then next thing I'm going to do is multiply that by 2. So this first term is going to come out to 6.125. Okay, and then let's see. 7 times 1.75 is that second term. I'm going to subtract that. So minus 12.25 plus 3. All right, so now let's do the arithmetic here. 1.25 plus 3, that's all going to come out to negative 3.125. Okay, so that's going to be then the y coordinate over here. Okay, and you know I can't get that accurate with my graph, but I can eyeball it here. So it's on this dashed line down a little. It's negative 3, a little less than negative 3. So I'll just put it right below negative 3, something like that. Okay. And then I can graph this. You could also reflect this point over, although it's a little bit of a pain to reflect because that's 1.75, so I'd have to go 1.75 out that way. So maybe I'll just not reflect that. But yeah, I've got lots of info here to get a pretty decent sketch then of the parabola. It's going to look something like that. And that, in a nutshell, illustrates how to graph a quadratic function in standard form. You use the intercepts and the vertex. And to get the vertex, use the axis of symmetry. Okay, and that's it for today. See you next time.